Welcome to what I hope will be the last part of this long series on the Zorki 6. So, this is the end of the road. Only a couple of things still need to be done, or at least put back. So we have the little bezel on here, the trim here, and bottom plate, leatherette on the back, and the two locking screws here. I've also had to replace this, which meant taking the shutter out of the body again, because there was a strange behavior. I mean, it's not strange, it's totally explicable. Strange in the way that sometimes, I think more often than not, when firing the shutter, I mean, after firing the shutter, the cocking, let me see how to explain. So usually you cock the shutter, you fire, you cock the shutter, you fire. Well, most often than not, I would cock the shutter once, fire the shutter, and then at the next stroke, only about here, I would hear a very faint click, and then I would need to cock it again. And what happened, on this little gear there's a pin. On the sprocket shaft, there's another pin. Now the pin from the sprocket shaft engages this pin, so it hits this pin here on the left, and thus when you cock the shutter, the motion is transferred to the shutter itself. Now if this gear, this pin, and the sprocket shaft and its pin are not paired, let's say paired, what happens is that when you fire the shutter, this goes down, so this pin is released from the other pin, and this is what allows the shutter to move, so the shaft and the drum to spin. When you release the shutter, when you release or you lift the finger from the shutter button, this goes back because the spring plate on the bottom is no longer held apart or held at a distance. So this goes back, and this pin should fall in front of the pin of the shaft, of the sprocket shaft, by approximately half a millimeter or a millimeter. That's what Isaac Meisenberg says in his book. Alright, well, in this case, this pin was hitting the other pin from the shaft, and that meant that when cocking the shutter or the lever, the shaft, the sprocket shaft, let's say this is the pin from the sprocket shaft. Usually it has to be here. So when you advance or cock the shutter, the top pin pushes on the bottom pin and transfer the motion to the shutter. Well, in my case, because this gear would go back in position with its pin hitting the upper pin, when I was cocking the shutter, first of all, the upper pin on the sprocket shaft would rotate clockwise and would slip and fall in front of the lower pin, and then I would have to continue advancing until it would make one complete rotation and it would fall behind the lower pin, and only then I would be able, or I was able to actually cock the shutter. So What this means is that it wasn't only like a double stroke action, but doing that would mean that the film was advanced or was being advanced without cocking the shutter. So you would pretty much get large chunks of blank film between the actual frames. And all that happened because probably this little guy, so this little pin, was a very, very small bit different. Or the entire gear was a very little bit different, like maybe one tooth off or something. I don't know. I didn't count the teeth on both gears. They looked the same, but obviously they weren't the same, or they aren't the same. So this one goes back with the original shutter from this camera and all the other bits, and it will probably be installed in my Zorki at some point. And pretty much that concluded my adventure. It was quite an adventure. I didn't expect so many issues. I honestly didn't expect so many issues from a camera that was functioning pretty much properly from the very beginning. Obviously an old camera with, well, with some lack of maintenance, but it was functioning, and getting from there to a camera serviced in the sense of cleaned, lubricated, new curtains, alignment, and I didn't messed up anywhere in that sense of really fucking things up. My only mistake was that of not getting the line on the drum in the first place, but that was an easy fix. All right, so yeah, the feeling was kind of daunting to see that I started with a good camera and I just wasn't able to, I don't know, to figure it out or make it work. Anyhow, it works now, so that's good. I timed myself from starting to take everything out this morning. So it was pretty much in this state, and I had to open it up again, pull out the shutter crate, replace the piece, and put everything back. And I timed myself 46 minutes. It could have been, I don't know, maybe 5 minutes less, or maybe 40 minutes, but I really struggled getting the shutter back. I don't really understand why. I think I was in a rush and probably I didn't pay enough attention. Anyhow, yeah, so when you know what you're doing, meaning that you already know the internals of the camera, you know the sequence of disassembly and reassembly, things can go quite fast, and obviously I lost many hours talking in this series, but that was the purpose of the series. I mean, not me talking, but I don't know, me explaining. All right. For this episode, I will refer to the final adjustments. And I will start with adjusting the focus. You have this inner lens, which is actually a very shallow prism that can rotate, and by rotating it you are moving up or down that little rangefinder patch that you see in the viewfinder. And this is the first adjustment that you must do. So first of all, adjust for the vertical, then adjust for the horizontal. Now, even if the horizontal adjustment was okay when you started with the camera, messing with the rangefinder assembly, so taking it out, cleaning and putting it back, will most certainly lead to a misadjustment. In this case, it was quite extreme. No biggie, so it's very easy to adjust it. Put the lens back on the camera, focus the lens to infinity, and find something that is very, very, very far away. I have a block of flats, like, I don't know, 500 meters away from my window, and that is my usual point of focusing when I'm adjusting for infinity. So adjust the lens for infinity. It should be a good known lens, because this is where the tricky part starts. You need to have something that is correct, so that is precise, in order to actually be able to adjust the camera. Otherwise, you would be adjusting the camera for that particular lens. And it goes even further than that. If the lens is not collimated properly, so basically the working distance of the lens is not the correct working distance of this mount, so of the LTM or M39 or L39 mount, which is 28.8 millimeters working length for the camera. So if the lens is not collimated for that working distance, what happens is that when the lens is focused at infinity, the projected image will not be where the film is. It will be either in front or behind. Now, I still need to check tomorrow during the day if this lens focuses correctly on one of my good known bodies. So let's assume that my FED is the good known body, and I will confirm it in a moment. Okay, so in my situation of not having a lens collimator, and that thing, if it's the real deal, is extremely expensive. So some good $1,000 or euros or whatever. So not having one and not having an improvised one, I need to rely on a depth caliper with which I can adjust a body and then test the lenses on the body. That's kind of my approach for the time being. I will probably slowly, I don't know, make my own collimator, or I'll see what I can do. It's not something that I'm really eager to do, because I don't think I have the know-how and the means to do that. But let's assume that this is the good known body. Now, first thing, when you measure the working distance, so you need to get the caliper inside, and the tip of the caliper will press against the pressure plate. Now, if the springs of the pressure plate are weaker than the spring in the caliper, the tip of the caliper will actually push down on the pressure plate, and even if it pushes it down extremely an extreme minute distance, it is still more than enough to mess it up. So what I do usually, I get a cotton pad for taking off makeup or something, and I need the scissors. Cut off a piece, doesn't have to be too much, that I will actually stick behind the pressure plate. Now, when I'm doing this with other older rangefinders like the Fed one, Zorki one, the bottom loaders, I think I should. Just a second. Yeah, no, it's okay. So when I'm pushing down on the pressure plate, it's quite solid, so that's okay. So when using or calibrating bottom loaders, what I usually do is doubling the little springs behind the pressure plate. So the bottom loaders have a round, usually, or circular pressure plate that is simply put on, and it has two spring plates like this beneath it. So between the pressure plate and the backside of the shell. And I simply double. So I have a pair of those springs somewhere around here, and I usually put two, one on top of the other. So a set on one side, a set on the other side, and that doubling increases the resistance of the pressure plate enough so that it won't move. Then, I don't know if this matters or not, but I got used to getting a piece of film. Alright, so the film, the back is closed, and now I have that piece of film that mimics the actual film as it sits in the camera, and then I take my caliper. Usually I align that circle to be right in the middle. The middle point is what I'm most interested in, and it shows 28.805. So that's what I would call spot on. I am 0.005 or 0005, I'm not really sure this hour at night, but it's pretty much exactly what it's supposed to be. And if I only touch it, it goes to 28.80. So a simple touch will give you a different reading. Of course, the tolerances are insane. If I move my reading to the corners, 28.8 on that corner, 28.815 on this corner, 28.79 on this corner, and finally 28.77 on this corner. I don't care about this corner. So it is what it's supposed to be. So this is my go-to camera that I use to calibrate to check lenses, because it's a simple math equation. So this is, let's say this is A, and let's say this is B, the lens, and let's say that this camera is C, right? So if A equals B and B equals C, that means C equals A. So pretty much with a camera and then a good known lens, I can then check another camera and either another camera and make sure that camera is okay and not go through this procedure, or I can check another lens on this body, and if that lens focuses correctly on this body and it also focuses correctly on that body, it's obvious that the other body is okay. All right, so this is what I do with my trusty old and funky Fed 2, which, by the way, is smooth as fuck, excuse my language. Now this is one smooth camera. All right. Now, then, I will get to checking. No, actually, no. If you remember, at the beginning of the series, when I started the disassembly, I found no shims behind the lens mount, and that's a bit strange. Given the tolerance, so you pretty much, even if you tap, not to mention if you touch the needle it goes haywire. So the tolerances are insanely small. So you have a distance from the lens mount to the film plane of 28.8 millimeters. The acceptable error is 0.02. In some places I found 0.03, in other places 0.02. Let's say it's 0.03. That means if this is the correct working distance, so 28.8, this is too much, this is too little. So this is the maximum acceptable error. This is 28.83 and this is 27.77, and that's the range accepted. I find it impossible, especially for the Soviets, to machine a die-cast body so precise that when everything is put back together, so when you got the lens on the body, everything is tightened down, you are within that kind of tolerances. It's not possible. Why there were no shims under this mount, I don't know. It's not just one example. I've opened two other Zorki 6s, so one, both are mine. One is the one with the problem and with the donor shutter, and another one, I'll see what's the story with that one, but neither of them had shims. And I'm pretty confident that when I'm going to open the Zorki 5, I will find no shims. Why they didn't use them, I have no idea. Now, since there are no shims, there can be two options. Either the distance from the lens mount to the film plane is too small, in which case I could increase the distance by making my own shims. I have all sorts of, this is rice paper, this is an original, I think, piece of shim from, no, it's not original. I made it from, I don't remember what kind of paper. This is an original bit. This one is about 0.03 or 0.1, I don't remember. This one is Teflon, cooking Teflon, and it's 0.04, I think, and this rice paper is 0.02. It doesn't really matter, I have a couple of options, so in theory I could use that to increase it. But the other option or variant would be that the working distance is too big, and if it's too big, there's not really much that you can do except starting to, I don't know, sand some parts down, rectify the lens mount. I don't know what you could do realistically, and I don't think it's worth the trouble. I did measure the distance on this one, and it was a bit too big, and we'll get to that in a moment. So what I did, I checked, I adjusted the infinity for this lens, which is the lens that came with the camera, and then I checked that adjustment on the film plane. This is the big advantage of having a regular opening camera, or a camera that opens like the Fed do, so the entire back opens. What you need is a ground glass. This is the best option. This is a ground glass from a Praktica, and it has a diagonal split screen. And it's seated on the inner two rails only. You have one set of rails here. These are the rails the film travels on, and you have another set of rails which are a bit raised compared to the inner ones. So if you put the focusing screen on the outer rails, you'll mess up the adjustment. All right. So this corner sits on that rail, that corner on the other rail, two pieces of tape, and it's seated in position. Lens focused at infinity. Now the lens is just a tiny bit off the mark. I'm not really sure why. There is no other option. I mean, I can't adjust it like this because under each screw there is a dot or a hole on the piece beneath this ring. Anyhow, so lens focused at infinity, rangefinder adjusted for infinity, and then shutter set to B, like this. Open the shutter, twist the button, the shutter remains open, aperture set to f2, and then I would look at that distant building with this piece of beautiful Carl Zeiss Spankular lens that I messed up a long time ago, that I'm now using as a loop. Of course, you can use a regular loop. The bigger the magnification, the better. This one magnifies a lot. I don't know how much, but it's 5x or more. It's probably more. So I would simply use this to see if that split screen in the middle of the focusing screen is correct or not, is aligned or not, and it was. So that was okay. That is one check for infinity. The other check would be for close range. Now, there is a difference between the rangefinder arm of a Leica, or maybe Japanese cameras, or other cameras, which is basically an arm and a rotating round part at the end. So that rotating part is actually what reads this. So going in and out, in and out. That rangefinder arm moves again, presses against this ring and actually reads the position of the focusing helicoid. The Soviets use this wedge instead of that round shape lever end. So this wedge, because it is articulated here, if you rotate it like this, or not rotate it but adjust it like this, the end, the tip of the wedge that actually comes in contact with that ring on the lens moves forward or backward, and this is how you adjust for close focusing. Obviously, when you do this, you will decalibrate the infinity, so it's back and forth. You adjust for close focusing, then you for the wedge, then you adjust for infinity the rangefinder, and then you recheck close focusing, maybe readjust it, and so on until they both coincide, which is not nice. It's not a nice procedure. All right, but I did check it I don't know, 3 meters away or something like that, and it was okay. And they are calibrated in a factory, so as long as you don't mess up the wedge when you get everything out and you clean it, you are good to go. All right, I will take this off. I'll probably recheck it in the morning just to make sure I didn't miss anything. Okay, then get the pad in there, get the piece of film, right, close the back, and take a measurement. And believe it or not, it's 28.83, so it's within the specified values, right at the upper margin of possible values, but it's there. This corner 28.83, 28.84, a bit out of spec, 28.84 and 28.83. So the working distance is a bit too big or too long. Therefore, I have nothing as no option to shave like 0.001. It's not possible. What I can do is try to tighten the screws just a bit more. And that usually fixes the problem, usually, but not this time. It's the same. But I would say it's pretty okay. I mean, it's a lot better than I expected. I actually feel the working distance is even bigger now than it was with the screws tightened more decently. Yeah, 28.83. All right. So in mysterious ways, the Soviet things work. I don't understand how they managed to get it so precise, but well, good for them. All right. This was the working distance and rangefinder adjustment. Of course, the lens, adjusting the lens or the working distance of the lens is a different matter altogether. I'm not an expert of any kind, so I will not get into those details now. The shutter is pretty quiet. Now, adjusting the shutter, which is the second adjustment procedure that I will cover, and that will be the end of this video and of the series. The shutter adjustment requires you to adjust the tension on the two spring-loaded rollers so that you get the correct shutter times. Now, what is the correct shutter time? In theory, or ideally, it would be a shutter speed determined with a shutter speed tester that's, I don't know, 20% within or 20% off the actual value. Now, if the actual value is 500 or 1/500th of a second, that means 2 milliseconds. So you'd need to use a shutter tester, which I personally don't have at the time. I mean, I do have an Arduino based laser tester, but I'm not convinced that it works properly, so I prefer to trust my eyes, and I'll explain in a second what I mean by that. Okay, otherwise you adjust it by ear, as described in even in Meisenberg and in some other resources for the Soviet cameras, and not only Soviet. My experience so far is that as long as the curtains are in the correct position and as long as the adjustments are made with a, I don't know, a common sense, let's say, the shutter will work. It will not be super precise. I wouldn't recommend shooting the once in a lifetime slide film that your life depends on one of these cameras. No way. But it's more than enough for black and white and color negative film. And what I also found during my brief experience fixing these cameras is that you can't really get it wrong as long as you follow a quite simple recipe. So what I usually do, after the shutter has been reinstalled, all bits and pieces, I usually release all tension on both rollers and then start fresh. Starting fresh usually means 3 full turns on the first curtain, 2 full turns on the second curtain. That's usually the base tension, or the base point of tensioning the shutter, and I would increase those values slightly or slowly until I get my desired results. I did have one Zorki 1, I think it was, that actually required a lot less tension to actually work fine. That was totally surprising because that was an older camera than this one, and I was assuming the springs were a bit more tired. Anyhow, when you get these two initial values, you start checking the times. The first basic check is to see that it works on B, and by working on B, I usually mean that the second curtain goes all the way back. That's one test. Then you go up the speeds 30, 60, 125, 250 and 500, and you check that you don't have shutter capping on 500. So when looking to a light source and releasing on 500, you should see a clear image. If you only see light on the left side of the film gate, you have an issue, but that issue is usually not related to the the tension in the shutter, because that means that the second curtain starts too fast. It gets in the shutter before the first curtain has the chance to open, and then moves slowly or slower. So that usually is a timing problem. If on the other hand you see light only on the right side of the film gate, that means the second curtain catches on the first. So the first curtain starts moving, the second one starts moving as well, you see light, the second one goes faster than the first, so it catches up and closes the gap. So you'll pretty much, you will see light here, but you won't see it here. All right. In that case, you either increase tension on the first curtain or decrease tension on the second curtain. I find that decreasing tension on one of the curtains, the one that needs decreasing, is the better option. The less tension you have, the nicer the camera will feel. It's not always possible, not necessarily possible in this case, but that's my preference. I would rather have a slower shutter because obviously the shutter speed, or the speed of the curtains as they travel will decrease. A slower traveling set of curtains will automatically mean longer exposure times, because the gap between the two is predetermined by that little disc with the slots in it, or the holes in it. So the release time of the second curtain is predetermined. The slower they move for the same gap, the longer or the more light will hit the film, thus increasing the shutter speed, the actual shutter speed. But I would rather lose even one stop. That's my personal preference. I would rather lose even one stop of shutter speed if that means I will have a very smooth experience than have a crisp and clunky and loud and rough shutter that is accurate. Because as long as you determine, or you manage to find out what the real shutter speed is, you can compensate. And I usually use these cameras more like f16, Sony f16 kind of approach. That means I'm usually at the 1/25th setting, because I rarely stick 400 film inside, and even if I did, I would compensate through the aperture if possible. Obviously, if it's super sunny outside, you kind of need 1/500th, and that might be a problem. Okay, what I use to actually calibrate the shutter as a second step of the calibration would be my phone. It's a Huawei P30 Pro. It has a slow-mo option that works very nicely. Look, I've got a Zorki. A Zorki 4, the flipped image as a phone cover. So the slow-mo option is quite nice. It triggers automatically when it detects movement, and I will try to get one now, just so that you understand what I mean. I'll get the shutter to 250 because it's a lot easier, or at least somewhat easier to record. Okay, slow-mo. I'll get the camera here, hit record, release the shutter. It's now recording. Okay, saving, please wait, no problem. And now, okay, so this is the shutter. I will play the well, obviously it had to not work when I'm trying to prove a point, but I will try again. Okay, so I hit play. You see the gap in slow motion going from one side to the other. This was 250. The phone records the slow motion at 960 frames per second, so it's quite nice. All right, and with that slow-mo, I can assess at least partly accurately the way the gap moves. So I can see if the gap increases, which means too much tension on the first curtain or too less on the second curtain. I can see if the gap decreases, which seldom happens. I can pretty much make sense of how the shutter works. So that's the second kind of test that I can do. And the most important one that I use all the time, and it has never failed me, is my Mobitronic, that's how it's called. It's a very small CRT monitor or TV set it was used for surveillance, I don't know, 30 years ago. It's like this big, bolted to a shelf right there. So it's at eye level, and I always check the shutters with it. Now, the theory behind it is that even if there is no signal in the TV set, it will refresh at a given refresh rate that is given by the refresh rate of the current, or the power in your how do you call it, a wall socket. Okay, so it's either 50 or 60 hertz. Don't take my word for it. I know very little to no electronics, so I don't know if it's 50 or 60 hertz or double that. Anyhow, let's say it's 50. So each beam of electrons will go from top to bottom on the TV set like this, and another row 50 times per second. That means that when the shutter moves, so you release the shutter and there is a gap. This is the gap that moves from right to left. So the gap moves from right to left, and the electron beam, the light, moves from top to bottom. So that pretty much means that you will get a slanted and oblique line like this. And by looking through the film port towards the monitor, when you release the shutter, you will see one strip of light like this. Obviously it will be more or less narrow or more or less wide according to the shutter speed. The width of that stripe of light is, I don't know what is the correct width. I'm kind of used to how it should look at 500th of a second or 1000. At 1000 I think it should be 1 millimeter wide, so it's a very thin strip of light. For 500th of a second it should be double that, so something like let me see. I'd say usually this is the kind of width I get for 1000th of a second on Zorki 4s. Now this is 2 millimeters, so I don't know if it's good or bad. Obviously the width of the slit must be correlated with the traveling speed of the shutter. So if the shutter is traveling slowly, it needs to be very thin or narrow. If it's traveling very fast, it needs to be wider. So it's not enough to just see or even measure, if you could, that width of the stripe or strip. Let's what is it called, a stripe or a strip? I mean, I know what a strip is, but anyhow, so it's more than just the width, it's also the speed. Unfortunately, the old school Leica tester, the guys at Leica used to have a drum with a light bulb inside, and the drum had a number of very narrow slits or slots in it. I don't really remember right now. I think they were 1 millimeter thick and something like 27 or 30 or something number of those strips across the circumference, and the whole thing would rotate at a given rotation that could have been adjusted like a record player. So they knew the exact rotation of the drum, they knew the dimension of each slit and the number of slits, and so they could actually calculate how many strips of light they would see while releasing the shutter. But in that case, there wasn't only one row of light moving from top to bottom. There were several, so they would be like this and going down if they were 4 millimeters apart and this is 24, you would have like 6 of them or 5 of them moving any given moment throughout the film gate, instead of this monitor that only gives one and it moves 50 times per second. So if the shutter speed of the curtain traveling time, so the time needed for one curtain to move from one side to the other is, let's say, 25 milliseconds, which is kind of slow, but it's probably somewhat what the Soviets used. I suppose it's somewhere like 20, 25, maybe even higher. So if the gap between the curtains takes 25 milliseconds to move from one side to the other, I'm really poor at even this kind of basic math. So 50 times per second means 1000 milliseconds divided by like 50, right? So it's 20. Okay, so once every 50 hertz means 20 milliseconds from top to bottom. So each row of light takes 20 milliseconds to go from top to bottom. If the shutter moves in 20 milliseconds, let's assume that 20 milliseconds is the correct shutter speed or curtain traveling time. So it takes 20 milliseconds to go from here to here and 20 milliseconds from here to here. That means at any given time you will have one strip of light moving from top to bottom, or maybe two that you would get, or that will get you one oblique strip of light in one corner and another one in the other corner, but usually you only see one. You have to see it to understand what I'm talking about. Anyhow, what it really does for me is the fact that let's say that this is that oblique strip of light, obviously a very big one, but it shows me if this edge is parallel to this edge, and that tells me how one curtain's speed is compared to the other. So if this edge is like this, but this one is like this, it means the second curtain is too slow. If it's like this, it means the second curtain is too fast. Or it means this curtain is too slow, or this curtain is too fast. But usually it's something like, I don't know, maybe 45 degrees, I don't know, but I usually see it like this. If I see it like this, it means the entire shutter moves too slowly, because if the speed of the shutter, the traveling speed of the shutter is 0, let's assume, you would get a vertical line, right? Because the gap is stuck there. If the traveling time or traveling speed of the shutter is infinity, you would get a horizontal strip of light, because you would only see one row, that one row of light being frozen in time. All right. And yes, if it moves in 20 milliseconds and this moves in 20 milliseconds, that would give you a 45-degree angle, right? I think. Anyhow, that's how I use my monitor to balance, because that's the correct term, to balance the curtain speed. So as long as I have both curtains traveling with the same speed, and as long as they seem right, normally snappy on bulb. See, in this case the second one seemed a bit slow, but for the usual shutter speeds it works correctly. I will recheck it tomorrow. So as long as you have that snappy motion of the curtains, you are pretty much okay. Adjusting, drastically increasing or decreasing the tension will not give you proportional results in differences in shutter speeds. So if you have, let's say, 1/60th, you get a real shutter speed of 1/30th, you can increase the shutter tension all you want, you won't get 60. It's just not physically possible. So changing the shutter tension will change the actual shutter speed, but within limits. The biggest importance is made by the actual insertion point or attachment points of the ribbons and the shutter curtains. That's why it's important to not mess it up like I did. Okay, that concludes our series on the Zorki 6. Another series on the Zorki 5 will probably follow, but it will not be in depth because it would be insane. It's the same camera, it only has very, very small differences. I will cover those differences and probably have 1 or 2 episodes, and maybe I will make another episode when I get my test roll out of this camera and see what's what. Thank you for your patience. I hope it helps someone, so I didn't talk for myself, and I hope you learned from my mistakes and yeah, and get your cameras serviced. Don't mess them up. See you next time.